Hello students, welcome to another video lecture for the lab of CompSci 137, Data Communications and Networking. In this video, we're going to talk about the IP routing. Let's get started. IP routing is third lab for this course. And we have the following outcomes at the end of the session. You should be able to describe the IP addresses, specifically IPv4 and IPv6. Second, differentiate network classes. Third, explain how router and IP routing works using routing tables, and configure hosts that belong to different networks using a network simulator. These are the outcomes for this lab. Okay, so let's talk about IP addresses. So IP address, an internet protocol address, is a logical numeric address that is assigned to every single computer, printer, switch router, or any other device that is part of a TCP/IP network. It is used to uniquely identify every node in the network. Remember that in the TCP/IP protocol suite, we have different layers of addresses. So we have a 4-layer model of the TCP/IP. So we have here the physical data link. Then we have here the network. Then we have the transport layer. We have the application layer. So the physical data, when it comes to addresses, we have the MAC address here, or the physical address. The network layer here, we have the IP address. So the IP address is used to identify each node in a TCP/IP network. It's a logical number. It's usually for IPv4. It is a 32-bit number written in dotted notation. We'll see that later. And we also have a term called static IP address. Static IP addresses are those types of IP addresses that never change once they are assigned to a device or a network. Not really, but when you say static assignment, usually this means manual assignment of IP addresses. Then dynamic IP addresses, these are IP addresses that change each time the device connects to a network. The important thing to remember here is that the way, the manner in which the IP address is assigned. If it is assigned manually, then it's called a statically assigned IP address. Whereas if it is assigned, let's say by a DHCP server, it's called a dynamically assigned IP address. And there are two types. There are two types of IP address. We have IPv6 and IPv4. And IPv6 is an enhancement of the IPv4 IP addresses. But in this lab, we're going to look at IPv4 addresses, which is a 32-bit address. And as I mentioned, it uses the dotted decimal notation. Here we have a comparison of difference between the IPv4 address and IPv6 addresses. You have the IPv4 on the left. You have the IPv6 right. So notice that the IPv6 has, in terms of the possible combination, has more possible combination of IPv6 addresses. But we'll discuss this later in the lecture, what the meaning of these IP addresses. IPv6 addresses, what these components of the IPv6 addresses mean. But for this lab, we're going to focus on IPv4, and here are some examples of IPv4 addresses. 32 bits written in a dotted decimal notation. Let's look at the part of an IP address. An IP address is a 32-bit number, as mentioned, that uniquely identifies a network interface on a machine. An IP address is typically written in decimal digits, formatted as 4 8-bit fields, separated by periods, shown here. Each 8-bit field represents a byte of the IP address. 8 bits, 8 bit, 8 bits. So the maximum value is for each part here is 255. 0 to 255 is the range. Now, given an IP address, it actually has two parts. It has a network part, which identifies the node or the host belonging to a given network. And it also has a host part. So when you see an IP address, it's not just a single, it does not just have a single information. It contains two information. First one is the network part of the address. The other one is the host part of the address. It's important because the network part identifies in what network a particular host belongs. And that will be important when we talk about routing later. All nodes on a given network share the same network prefix. So you call this the network prefix or the network part, but must have a unique host number. We also have a separate lab for IP address calculations, computations, but we'll discuss that next meeting. But for now, it's just important for you to remember that if you're given an IP address, it has two parts, the network part and the host. Some definitions, two or more hosts are said to be in the same network if they have the same network address. So this means that if you are given an IP address, two IP addresses, for example, and you are asked to determine, are these two hosts with these IP addresses belong to the same network? To determine that, you have to extract the network part of the IP address, and if they are the same, then they are considered part of the same network. What do you mean by that? And you also have different classes of IP addresses, but we'll discuss this later in the next lab. But we'll focus on this class of IP addresses. So class C, in the starting binary address is 110, so 192.223 is the starting byte. So in this type of IP address, we have a network mask to specify. The network mask actually, so the default network mask specifies which part of the IP address bits represent the network. You have to specify the subnet. So this is important to determine which bits will represent the network part. So if today we're going to focus on the class C, so we have the default subnet mask of 255.255.255, that's 0, and network part, the first 24 bits derived from this, and the host part is the remaining 8 bits. So this IP addresses class C is actually used in your routers, in your home routers, for example. When you check your IP addresses in your machine at home, when you connect to your router, you will see these class addresses. Let's have an example. So if we have, say we have two hosts, and this one here is 192.168.5.7, and this one here is 192.168.7.2. So by examining, so we are asked, the question is, do these nodes, do this host A and B belong to the same IP network? So given their IP addresses. So the solution for that is to simply extract the network part. Now we are not given the subnet mask. If you are not given the subnet mask, then we're going to go back to the table presented here, which shows that the default subnet mask is this one, 255.255.255.0, because we did not specify, no subnet mask was specified. So this means that the network part of this IP address is 192.168.5.0. And for this IP address, the network mask is 192.168.7.0. Now, since they have different network part of the IP addresses, that means they don't belong to the same IP network. Therefore, in order for this to communicate with this network, there must be a router that will forward the data from this host to. So that's what we mean by. Okay, so I hope that's clear. You can try this. It's actually part of the. We'll just continue with this for the on the next lesson. Okay, so the next thing to remember is routers. What are routers? Okay. I mentioned the router is also called a gateway. It attaches two or more networks and allow a host from one network to communicate to a host in another network. So let's think of, let's go back to this illustration. Just to be able to differentiate the two. So let's go back to the layers again. Let's just refer to them by numbers. This 1, 4, 1. When we say network, we can think of the connection between one and one as a physical network. Okay? And the layer 2 and 2 represents the logical network or the IP network. So this means that, for example, these two nodes here, two hosts, they belong to different logical network. They can be connected to a switch, but they can belong to different logical network, which we will see later when we look at the simulator. The idea is, in order for two logical networks to be able to, two nodes in a logical network from different logical network to be able to see each other, then they need to have we need to have an intermediate device called a gateway. The routers will route packets from one network to the other unit until it arrives final destination directly across one physical network. This is done by accepting and transmitting IP packets and is called forwarding. A router usually has two interfaces where you assign the appropriate IP address. In practice, one interface is configured to become part of a local network. The other is configured to be part of a network of routers. This is an example illustration. Here we have two hosts host 1 and host 2. Then we have two routers here. This is one network. Let's examine the figure. We have this network here, 192.168.0 network, and we have 192.168.1 network. And they belong to different logical networks. And for them to see each other, we have to connect them to two routers. This will serve as the gateway for the second network, and this one will serve as the gateway for the first network. See here some of the mappings. We have three networks essentially here. We have one here, second one, and the third one. Okay, how does the routers maintain, or how do routers maintain, how do they forward packets across network? They maintain a routing table, and this routing table contains information when where to forward a packet it receives in case that it does not belong to the network where it came from. It goes outside. It goes outside of the network. And we have the following fields usually in the routing table. We have the destination, the next hop, the interface where to forward the packet, and metric, and route. For example, in figure 1, host 1 wants to send a packet to host 2. Since the source of the packet is not the same network as the destination, host 1 would pass the data to router 1. Okay. Router 1, the routing table will be consulted as to where the packet will be sent to. The routing table of router 1 should look like this. When it receives a packet destined for 192.168.2, it should have an entry like this. Okay. So let's in this lab we're going to use a simulator to do that. So let's start with the simulator. So this is called Scalable Cisco IOS simulator for virtual network. This was developed part of the undergraduate special problem of some of the alumni, previous alumni of student of ICS. So we have these students here way back 2002, and we've been using this to illustrate IP routing. In Cisco, so it's actually a Cisco IOS emulator. Cisco also provides, I think it's a free tool called Packet Tracer that will allow you to do the same thing, to simulate networks, but in a more advanced manner. But in this our class, we're just going to use the simulator because it's simpler. So you can try, of course, try the Packet Tracer. Okay, so let's start with the initial configuration. In this simulator, we have the working area here, and we have the tools or the devices on the left. So let's say we want to create two hosts. We have host 1 here, and then let's have another host 2 here. And let's say we want to connect them using a cross cable. So you right click on host 1, and then you add a connection, click add connection. Then you select the interface. So notice that the host 1 only has one network interface. Let's click this, and it will display a dialog box that will allow you to choose which host to connect to. Since in our drawing area, in our work area, we only have two hosts, we select host 2, and host 2 only has one interface, meaning one LAN card. Now let's call this one a LAN card, and this is the name of the interface, Ethernet 0, and when we click apply, we get the connection. So you can think of this as connecting these two devices using a cross cable. Remember, you use the cross cable to connect two similar devices. So this is the first step that we need to do to physically connect two nodes. The next step is so these are physically connected. This means that there is a physical network between these two. Now we're going to configure this to have a logical network using IP or the Internet Protocol. We said that we need to assign IP addresses to each host. So let's right click on host 1 and then configure this. So let's use the class C addresses, and as shown in the previous example. So let's use this IP addresses here, 192.168.5.7 and 192.168.7. Error. 192.168.5.7. Now, automatically, the tool will provide you with the default subnet mask, so you can leave that as is, and then you click apply. You leave the default gateway to 0 for now. Then you apply, and then for the other host, also configure it. Let's look at the IP address to assign 192.168.7. 192.168.7. And then when you click on the next input box, you get called subnet mask. And so obviously you can see that they don't belong to the same logical network, logical or IP network. So we can test the connectivity. So the ping command in most ping command uses the ICMP protocol, which is actually part of the IP layer. So if we ping the other machine by the IP address 0.7.2, what do you think will be the result? Will the ping succeed or will it fail? It will fail. Obviously, because they don't belong to the same logical network, same IP network, because they have different network part and their IP addresses, although they are physically connected. Okay, so the solution is let's say we have to change one of them to the IP addresses so that they will belong to the same network. For example, let's change the IP address of host 2 to 192.168.5.10. Let's configure this 5.10. So obviously, they should now be able, or host 1 should now be able to ping the other node because they now belong to the same logical network. Okay, so that's the essence of that. Initially, they were connected physically, connected, so they belong to the same physical network. But at the logical network level, the IP network, since they don't belong to the same network because of they have different network part in their IP addresses, they cannot see each other. So what our solution was to simply change the IP address of host 2 for it to become part of the logical network of host 1. Now this is not scalable, obviously, because you only have a limited number of, let's say this is a class C network. So the host part is only 8 bits. So you will be limited to, let's say, 254 hosts per network. What if you have a very large network? So normally you're going to use a different logical network to accommodate those. Right? So what we can do is add a router or an intermediate device. Let's first let's remove the connection. So let's say we want to have this network. So they belong to the same network. Because they both have 192.168.5 as the network part. Now, you can actually introduce a switch, say this simple switch here, and at this moment we're just connecting the two nodes using cross cable. Okay? But later on we might want to add more nodes, and to do that we can use a switch. So we can remove the connection here between the two nodes. Connection, right click, no more connection, and then we create a connection to the switch. And you will see now that since we have two entities on the work area, we select switch 1, and normally a switch has several interfaces. In this example, we have 12 Ethernet ports in the switch, and we have 2 fast Ethernet ports. So let's just connect to the Ethernet port, switch, Ethernet, the first Ethernet port, and we will see this. Now, if we ping the other host, what do you think will the result be? It will fail because there is no physical connection yet. So what we need to do is to connect host 2 to the switch also. Right click, add a connection, select the switch, and then we select the second Ethernet port. Then we now have a connection. Then you can now ping 10 because they are now physically connected. Okay? Now, when it comes to routing, let's add another host here, host 3. And let's use the address here, 192.168.7.2. Configure this 192.168.7.2. Automatically the subnet mask will be generated, and then click the right click and then properties. Now have these properties of host 3. The next step is we want host 1 or host 2 to be able to see host 3. Okay. What can we do to accomplish this? So we don't want to directly connect host 3 here because it has a different logical network. What we can do is to introduce a router. So this is the 2600 router, and then so we have now a router 1. We're going to configure router 1 so that when it receives packets from a host, it will be forwarded to the appropriate host. I forgot to mention about packets. So in a typical packet, usually, recall our discussion in the lecture about protocol data units. So we have the source address and we have the destination address. So these are fields in the packet, and they are examined by the router whenever they forward packet. So in addition to other data here, there are other data here. Important to the concept of routing is the source and destination addresses, or the source and destination. Going back, we now have a router, a device that performs packet forwarding. So the first thing that we need to do is to connect this network to this network. So we can actually do this by just Clicking on the router, right click, then we add a connection. So normally a router has 2 ports. We have here 2 ports. So if we select the first port, then we connect this to switch 1, and then we use Ethernet 03, the third port. The 2 ports on the switch are already occupied, so we can attach to the third Ethernet port the port here. So they are now physically connected, okay? But there is still not, we haven't configured this router yet, okay? So we need to assign an IP address so that this node, this end of the router will be accessible from this network. So right click and then we go to console. So this will require us some knowledge of the Cisco IOS commands, network commands. Yeah. So in the lab we have, in the handout we have this guide for the basic commands for the setup. And I did not use the example on the handout. You are to try this yourself. But let's look at the command. So our goal, going back to the example, is to configure the IP address here. First, let's check the properties of this router. Before we assign an IP address, we first need to check which interface is connected to the switch and which interface of the router is connected to the switch. And by looking at the properties, we can see that it is the interface fast Ethernet 0/0 as the interface connected to the switch. So that is important when we configure the IP address. So we go to the console and then we press enter. Then let's look at some of the commands. The first command that we need to use is the enable command. So we are at router 1. We type enable and then press enter. And the prompt will change to the pound sign. Then we start the configuration terminal. So config terminal. You see the change in the prompt. And then we select the interface connected to the switch. So interface, as shown earlier, fast Ethernet 0/0. So the prompt will say config-if. So once we are in that prompt, we can now assign an IP address. So the syntax is like this. So IP address, syntax, then the IP address you would like to assign to that interface, and then the subnet mask. Normally, routers or gateways have a .254, the last IP address, or the first IP address. So in this case, we're going to use the last IP address possible for the network, which is .254. So to set our simulator, so it says IP address, and then we type in the IP address. So it's 192.168.5.254. And then we specify the subnet mask 255.255.255.0, and it should be good to go. After setting the IP address on the correct interface, we type no shutdown and then exit. No shutdown, then exit. Close the console, and when we look at properties, we now see that the fast Ethernet is now assigned 192.168.5.254, which belongs to the same network as these two nodes, 192.168.5, and this also 192.168.5. specified. If we ping that that IP address, the IP address of the router should be able to ping that from this host, right? So that means logically now have a logical network between this and this. So you can also try to ping from the other host. Yes, we can also ping from the other host. So the question now is, of course, we cannot ping here because it's really different network. So the next step that we can do is, since we're going to route packets, we can actually add a connection between the router and host 3. So we add a connection. Now this one is already connected, the first interface. So let's add the next 3 interface, host 3. Then attach it to the first interface of host 3. We now have this setup. Now, given this physical connection, we try to ping. We will not be able to do so. Why? Because the packet that came from here, let's say it has a source of 192.168.5.7 and the destination is 192.168.7.2. So they belong to different networks. So we have to configure the router such that when it receives the packet from host 1, it will forward it to this host. So we go back to the console again. Then we add a connection. Not add a connection. We go to the console and we type enable. Go to the config terminal. Then we select an interface, which is fast Ethernet 01. Then we specify the IP address 192.168.7.254. Then the subnet mask. Then no shutdown. Exit. And if we look at the properties of the router, we now see that fast Ethernet 01 is now connected to host 3. Okay. So that's nice. Now can we ping? Try. First, let's go to host 3, and then let's ping the. So we're pinging itself. Can we ping the IP address of the router? And yes, we can. Okay. Now, can we ping 5.254 other end? Cannot. Okay. So why is that? So let's look at the other end. So from this IP address, this ping 5.254 should work. If we ping 0.7.254, it work? It did not work. Why is that? Because we don't have routes yet, or we haven't specified a gateway. So I think we haven't specified a gateway. So right click on host 1 and then we click properties. Right click and then configure, and we need to add a gateway 192.168.5.254. So this means the gateway is actually consulted whenever the packet to be delivered is not within the logical network. So in case it cannot find the destination on the logical network, it will forward this to this gateway. So if you apply this, then we click ping, we should now be able to ping the other end of the router. See that? And the same also with the other node. We have to specify gateway 192.168.7.254. Apply this and should be able to ping 5.254. Great. So that means that the packet can now reach from here up to this interface. Now, can we ping host 1 from host 3? So, 5.7, try this. 192.168.5.7. We cannot. Right? Because there is no route yet. Let's try the other end. Ping 7.2. We can ping now. Unfortunately, yes, a default route has been created. So we can now ping the other end. The same with host 2. So we have 192.168.5.254. Apply this. Ping from we ping 192.168.7.2, get the result. But the other one, with the other node, cannot ping it can ping now. So default routes were actually configured. I just missed the IP address. So the default routes have been configured already. Okay. Now this is not the actual activity that you're going to do, but it illustrates how you're going to configure the router. Okay. So I will leave up to you to try this scenario here. Although we can do this actually here, but I want you to try this on your own. The main difference in our from our example from the example that I presented is that here you have two routers as described in this illustration. So that is part of your learning experience. So all the information needed actually are provided in this learning experience. We will not do this here so that you get to try it on your own. This is actually the challenging part, which is adding the routes. So you have to configure two routers set up instead of just one router. So to be able to do the assessment, which is this one, you have to at least try doing this figure 3 example. Okay, so I hope that gave you an overview on how to use the simulator. The only thing that we did not do here is the routing. So we can actually check the routing. Click console, table, config, terminal, show route. IP show route. There. So this is the routing table. This means that the entries here represent that for any traffic or any packet that is going to this destination, I use those connected interface on this machine. Then the same with 7.0, which is same setup. That's why we can ping from one node from host 3 to host 1 in our sample here. Okay, so it's possible to have more complicated routing entries because in the lab, in the actual exercise, you have 3 routers to configure and you have to specify the appropriate. Okay, so good luck on your lab exercise, and if you have other questions, you can just contact me through that workspace. That see you on the next tutorial.